how is this not a pyramid scheme?
All right, let me explain. Phil has recruited me and another guy. Now we are getting 3 people each. It's not a pyramid scheme. It's not even a scheme per se. I have to go make a call.
Last time I tried to show The Office in one of these videos, YouTube flagged it for copyright reasons, so hopefully it works this time. So the problem you see on the screen is something that we've been doing in previous units. We have a population, just one, it's all complaints about Dunder Mifflin Scranton, and P is the true proportion of complaints that are about Michael Scott, of all those complaints. So in this example, which we're not going to do right now, David Wallace, he takes a sample of 40 complaints and he's checking to see if more than 60% of them are about Michael. So we've got a null, we've got an alternate. P is the true proportion of complaints that are about Michael. He's checking to see if it's greater than 60%. It's a one sample z-test. We've done this, nothing too crazy here. But I wanted to show you so that you can compare it to what we're going to do next. Everything we've done so far has involved a single population. And in chapter 10, we're going to be looking at 2 populations. So I just can't not do a problem about The Office. Here's our 2 populations. The weekly paper sales made by the Scranton branch of Dunder Mifflin, and then the weekly paper sales made by the Utica branch. We can assume that both branches make over 2,000 sales a week, and we're going to examine the proportion of sales that are over $30 at each branch. So let's say we actually know what those are. In Scranton, we happen to know that the true proportion is 66%. Ithaca, I wrote Ithaca, gosh. I'm not from the East Coast, so I don't know. Utica, only 50% are over 30. So we have P1 and P2. Now we have 2 distinct populations. We've got Scranton, we've got Utica, P1 and P2. So David Wallace, our CFO, takes an SRS of 100 sales from Scranton and records the proportion that are over $30. We'll call that P hat 1. And then he does the same for Utica, but this time it's a sample of 150, P hat 2. Why are they different sample sizes? We don't know. Turns out it doesn't matter. We'll get into that later. For right now, just notice that we have 2 distinct populations. We have population 1 and 2. So we have P1 and P2, the true proportions from each population, and we have P hat 1 and P hat 2, the sample proportions from each sample. Now, if we can think of these 2 statistics as one statistic, we'll be able to use methods that we've learned in previous units to do inference now. So somehow we need to look at these 2 statistics, this P hat 1 and this P hat 2, and put them together. It would make sense if we compared, let's say, the difference between P hat 1 and P hat 2. So let's use some software and do some random SRSs of P hat 1 and P hat 2. So you don't have to actually do this. I've used software called Fathom to do this for us. So I just created a population of sales for Scranton and a population of sales for Utica that matched whatever they were, the 66 and the 50%. And then I just set up the software to generate random samples. So here's the first. We have an SRS of size 100 from Scranton. I think it's like 0.62 was the proportion of sales over $30. And then a sample of 150 from Utica. I don't know what that is. 0.5 something. And then here is the difference between those. And this difference is P hat 1 minus P hat 2. So we've calculated the difference. You can see it is positive, which would mean that P hat 1 was larger than P hat 2, or Scranton's proportion was bigger than Utica's proportion. And then since this is software, we can just keep doing this over and over. So I did it again, and I did it a bunch of times. Now let's focus on that last graph. What we want to think about is the shape, center, and spread of this graph. So in some of the blank space on your notes, if you want to take a moment, pause the video, see if you can describe the shape, center, and spread as specifically as possible. Pause the video now and do that. So the shape definitely seems approximately normal. We've got some weird stuff going on over here, and I don't know why it's all like curvy, I don't know, pixels, hashtag pixels. But it looks approximately normal. And if you look at the original 2 distributions, P hat 1 and P hat 2, both of those looked like they were approximately normal as well. So if we subtract them, we're going to get something that's also normal. Now the center, you have to think back to when we combined variables. The center of this distribution is just going to be the center of the first distribution minus the center of the second distribution. So the mean of distribution 1 minus the mean of distribution 2 is going to give us the mean of this distribution. Now for spread, you might remember a meme that I showed you, and I showed you that on purpose. It was so obnoxious that you can't forget it. One does not simply add standard deviations. No. What we must do to find the spread is we have to add the two variances and then take the square root. So the variance from the first distribution would be the standard deviation squared, and then the second distribution, standard deviation squared. We add those together, then we take the square root. That's the standard deviation of this distribution. Now, this distribution I have here, is it the true sampling distribution of the difference of p hats, or is it an approximation? Think back to the Beyonce lesson. Yeah, this is an approximation because it's not every single sample from both populations, it's some of the samples. The true sampling distribution of p hat difference would be every possible sample of size 100 from Scranton minus every possible sample of size 150 from Utica. That's definitely not what we have here. This is an approximate sampling distribution. All right, let's note a few things about the sampling distribution of two proportions just in general. Now, when I'm talking about two proportions, let's just say p hat 1 minus p hat 2. Just in general, this doesn't have to be about Scranton versus Utica, just any two proportions. And let's go in order: shape, center, and spread. The shape of the sampling distribution of p hat 1 minus p hat 2 will be approximately normal if each of the separate sampling distributions was normal. As a reminder with proportions, to see if a sampling distribution of a proportion is approximately normal, we're checking NP and N1 minus P, and they both have to be greater than or equal to 10. So for this sampling distribution of p hat 1 minus p hat 2, we have to check 4 things. I'm not going to read them all out loud, it'll take forever. But we need to check that NP and N1 minus P is greater than or equal to 10 for each population. If that's true, we can say that this sampling distribution is approximately normal. And we saw that in the computer software example. We saw that that was true. So that's shape. Next is center. The center of the distribution is just going to be P1 minus P2. It's the mean from the first distribution minus the mean from the second distribution. So just P1 minus P2. That gives us the center of our sampling distribution of p hat 1 minus p hat 2. Oh gosh, I need a drink of water. This is a lot of words. Okay, and finally the spread. So when we're thinking about the spread or the variability of this distribution, we said before, we do not simply add standard deviations, we have to add the variances. Now if you've forgotten how to find the standard deviation for a sampling distribution of a proportion, I have good news for you. You have a formula sheet. So here you can see you don't have to memorize anything. You can just look at this row for two populations. Here's the center, we just said that, P1 minus P2. Here's the whole equation for standard deviation of the difference of p hat 1 and p hat 2. And there you go. You don't even need that stupid meme, you can just use this. So here it is all written out for you. The standard deviation of p hat difference, or the formula sheet writes p hat 1 minus p hat 2. I'm not going to read that to you. And just remember, we need to check the 10% rule in order to use that formula, just like we did in previous units. So this is the sampling distribution for two proportions. We've got shape, we've got center, we've got spread. We're not going to spend much more time on this because it's exactly like when we did one proportion. It's just with two proportions. Instead, we're going to go on to an actual inference problem. So here's where David Wallace is actually taking his samples. He found 61 out of 100 sales that were over $30 at Scranton, and he found 84 sales that were over $30 at Utica. We're supposed to construct and interpret a 99% confidence interval for the difference in the proportion of sales over $30 at Scranton and Utica. Okay, we're going to start with p hat 1 and p hat 2, which I'm going to start calling p hat s for Scranton and p hat u for Utica. All right, now it doesn't say it, but anytime you see construct and interpret, that's a 4-step process question. So we're going to start with state. We will estimate the true difference in proportions of sales over $30 at Scranton and Utica with 99% confidence, and then this part is pretty important, where p difference equals ps minus pu. So I'm just clarifying which way I'm subtracting. Next, we have our plan step, and the conditions are the same as always, so it's very straightforward. First of all, we need to have random samples, and it did say that he was taking SRSs. This is not required that you write, but just so that we can chat about it. This is good. If you have an SRS, you can generalize your results to the population of all sales. So that's why the SRS is really important. Okay, now the next one I'm going to check is normal. For normal, I know it's a pain, but we have to check NP and N1 minus P for both populations. Now you can see here I'm using P hat 1 and P hat 2. That's fine. I don't, in this scenario, David Wallace doesn't actually know the true proportions, otherwise why would he be doing this confidence interval? So I'm using P hat 1 and P hat 2. All of those well over 10. And this is good because we'll be able to do all of our normal calculations involving z-scores, norm CDF, all of that. The last condition is independence. There are over 1,000 sales at Scranton and over 1,500 sales at Utica. They said in the problem, I think it was like 2,000 sales a week. I said in the problem. I completely made this up. It's 100% me. All right, and this is good because we can use our formulas. Now, as I was doing in the last unit, I'm going to start with a drawing here. And I'm going to do all the calculations in this plan step so that the do step is super easy. So we said it's normal distribution. So here I have my normal distribution and I've calculated the center of that distribution. I'll just label that right now. Okay, and now the standard deviation, I have set up all of my work and now I just need to plug all that in. Hold on. So I've got my center, I've got my spread, shape is clearly normal. We are going to do a 2-sample z interval, and this is key. Now that we're getting into 2 populations, or 2 samples, we do need to clarify what kind of interval we're going to make. So we're going to make a 2-sample z interval, not a 1-sample z interval, not a 1-sample t interval, or 2-sample t interval. This is a 2-sample z interval. Oh my gosh, I just feel like I'm talking way too much in this video. All right, to the do step. We need our z-star. So 99% confidence would leave 1% in the tails combined, which is 0.5% in one tail. So I'm going to do inverse norm for the area. I'm doing 0.005, which is 0.5%. Mean 0, standard deviation 1. There's my z-star. Now I just copy pasted this right from the formula sheet. So let's say it's been a while since you've done confidence intervals. You can look back to the first page of the formula sheet and they have, just in general, what a confidence interval even is. So here we go. In general, our confidence interval is our statistic plus or minus our critical value times the standard error of the statistic, or standard deviation. So there's our statistic. That was p hat 1 minus p hat 2. There's z, and then we said our standard error was 0.0634. Now here's where I think I messed up. Technically what we just did wasn't the standard deviation, it was the standard error, because did we use p hat or p? Yeah, we used p hat. We didn't know what p was, so we used p hat 1 and p hat 2 to do this entire calculation, so let's just fix that real quick. Is it a big deal? It depends on who you ask, probably. Standard error. Okay, back to the point. So 0.61 minus 0.5. You know what else I did wrong? You know, everybody has those days, right? Is that a Hannah Montana reference? Pretend you didn't see anything. Okay, now we do our calculations. All right, so our interval looks like it's negative point, I'm going to go out 4 decimal places, 1133 up to 0.2133. I'm sure there's tons of mistakes. I look forward to reading the YouTube comments about them. All right, now we get to the conclusion. We are 99% confident that the true difference in proportions of sales over $30 at Scranton and Utica is between negative 0.1133 and 0.2133. I've got the context. I've mentioned that this is the proportion of sales over $30 at Scranton and Utica, so that's good. This is a perfectly acceptable conclusion. All right, now, is it an interesting conclusion? 0 is in that interval, so it's not super interesting. We didn't find that Scranton was like light years ahead of Utica. And this kind of goes into the next question in your notes. Based on that confidence interval, what conclusion would you make about whether Scranton is better at expensive sales than Utica? Well, as much as I love Michael Scott, 0 is a plausible value for the true difference in proportions. And that means we don't have convincing evidence that either branch is better. If your confidence interval includes 0, that's telling you that there is a chance that the two proportions are exactly equal or pretty close to being exactly equal. If our interval was like from 0.5 to 0.6 or something like that, that would be good evidence that Scranton is better than Utica at these expensive sales. But if 0 is included, it's totally possible that both proportions are exactly the same. Sorry, Michael, but I mean, are we surprised? Not really.